An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords. The intercepted arc lies on the interior of the inscribed angle with the endpoints on the angle. So this is going to be our angle ACB, and you're going to say that it's going to intercept arc AB. So angle ACB intercepts arc AB. So this angle intercepts arc AB. So now we're going to talk about the measure of this arc compared to the measure of the angle. The measure of the inscribed angle in the circle is 1/2 the measure of its intercepted arc. So that basically means that if this is x, the arc is 2x. So let's go ahead and work with this example. The measure of arc ZWX is going to be double the measure of the inscribed angle. So if this is 115, this equals x. And so 2x equals, so it's 2 times 115 equals 230. So your answer is 230 degrees. Example B, find the measure of angle HAT. So we need to find the measure of this angle. If HT Okay, and then lastly, for the examples, it says find the angle of HAT. So the angle of HAT, remember this was x, so that's going to be our x. And then you're going to say that this arc is going to be 2x. So we need to find x. So 2x equals 215. Divide both sides by 2. X is going to equal, let's see, 107.5 degrees. That's 107.5 degrees. Hi, we're going to look at the measure of TSY. So this is arc TSY. That means that TOY is going to be x. So x equals 90. 2x is going to be equal 180. So this arc is 180. Okay, and then it says if OY, which is right here, is equal to 48, then this angle is going to be half of that. So 2x equals 48. Divide both sides by 2. X equals 24. So YTO, just highlight it for you, YTO is 24. Okay, next one, it says D is a measure of arc QT. Okay, so that means that this arc goes with this angle QRT. So x equals 53. And then this is going to be 2x. So 2x equals 106. That's 106. And then the measure of QR, let's highlight that, we need to find. So what makes this a little bit easier is that you actually have half a circle, which is going to be a semicircle, because this right here is a diameter. So if this whole thing is 180 and QT is 106, then that's going to be 180 minus 106, which is going to be 74 degrees for arc QR. Next, it says the measure of angle T. Angle T belongs to RS. So this equals 2x. So 2x equals 52. This angle is x, divided by 2, x equals 26. So measure of angle T is 26. And then the measure of TS, it's the same thing because this is, again, half a circle or a semicircle. That right there is going to be in yellow. And it's 180 minus RS, 52, which is equivalent to 128. Okay, next, let's talk about theorems. So if two inscribed angles in a circle intercept the same arc, then they are congruent. So I am saying that angle U is congruent with angle K. So U and K are congruent. I'm also going to say that angle L is congruent with angle E. Now you can double that, or you can make the hatchings just two that go across. Just depends on the person. Okay, number 3. If all the vertices of a polygon lie on a circle, the polygon is inscribed in a circle, and the circle is circumscribed about the polygon. Okay, obviously this is spelled wrong, but here's what it means. If I have a circle and I put a polygon, let's just say a triangle, in that polygon, you're calling this a circumscribed. So the circle is circumscribed about the polygon. That means it goes around the polygon. Okay, a triangle that is inscribed in a circle is a right triangle, if and only if the longest side is the diameter. Any angle inscribed is a semicircle is also right angle. So basically it's saying that this long side is your diameter. So that means that triangle RSQ is a right triangle. And it's also saying that angle R right here is a right angle. So angle R is a right angle. And this ST, so segment ST, is the hypotenuse. That's what can be said. Now, if we're looking at the last theorem, quadrilateral, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. These two are opposite angles, which means if I add them together, I get a supplementary angle, which is 180. So we're saying that angle L plus angle N equals 180, and angle A plus angle G equal 180. Okay, DEFG is inscribed in the circle with angle F equaling 58, and then angle G equal 108, excuse me. So here's what you need to know. You need to know that angle F plus angle D equal 180, angle E plus angle G equal 180. So angle E is going to be 180 minus 108. So let's see, 180 minus 108 is going to give me angle E. So I know that that's going to be angle E is going to be 72. Angle D is going to be 58 from 180. So 180 minus 58 equals angle D. So angle D equals 122. So I know this is 122 and this is 72. Add them all together, you get 180 from this and 180 from that. Okay, I, D, E, F, G is inscribed, in the circle. Find X and Y. So 5x plus 7x is the same thing as saying angle D plus angle F equal 180. So you're going to solve for x. So 12x equals 180. 12x, divide both sides by 12. X equals 15. X equals 15. Okay, and then you have to solve for y. Let's do that right here. So 17y plus 19y equals 180, because angle E and angle G equal 180. So then I'm going to say I have 17 plus 19 equals 36. Y equals 180. Divide by 36, divide by 36. Y equals 5. So then y equals 5. And that is your solution. Okay, J, it says find x. So we know that this is going to be the right angle. And we know that 3x equals 90 because that's a right angle. So x equals 30. Okay, and then K, find E, F, and G. So this is 90. I know that E plus 80 equals 180. So let's solve for E. Minus 80 equals 100. And then I know that G plus 90 equal 180. So G plus 90 equals 180. So solve for G. Minus 90, G equals 90. Okay. And then it says solve for F. F is in degrees. So if we say this is 94 and I have a diameter right here, I could say this whole thing is 180. So 180 minus 94 equals F. That's 106 equals F. So let's put this all together. E equals 100. F equals 106. And G equals 90. Those are all degrees.